In this example, we are asked to graph linear inequalities. Now, we can graph inequalities by hand using graph paper and a ruler, but typically the best way to represent an inequality graphically is to use a sophisticated graphing calculator, or for this example, I use the program within the text to graph these inequalities. And you certainly should too. It gives a nice pictorial representation of the statements. However, we don't need a sophisticated calculator or a graphing program to determine if particular coordinates satisfy an inequality. We can simply just check them. So you can see for this example, we have these three inequalities, A, B, and C. The first one here, y is less than or equal to 5/4 x plus 6. And what I did is I used the program within the text and made the graph of this inequality. And this is the graph here. And we can see that this is the graph of this inequality here because the boundary line here, we have a intercept here of 6. And here it is right here. And we have a slope of 5/4. That means for every positive increase along our x-axis of 4, we're going to have a positive increase along our y-axis of 5. So we'll do that. We'll just count off 4. 1, 2, 3, 4. And then up 5. 1, 2, 3, 4, and 5. And of course, we land right on the boundary line there. We could also count back 4. 1, 2, 3, 4. And then down 5. 1, 2, 3, 4, and 5. And of course, we're back on the boundary line. So this is the boundary line. And of course, this is read as y is less than, or all of the y's are less than this statement here. So we shade it below. But we can check if this inequality, or if we are shading the inequality, the right half of the inequality correctly by checking a few points. And they don't have to be anything sophisticated. As a matter of fact, I'm going to check the point 0, 0. That's usually very easy to do. So I have a coordinate 0, 0. I just go ahead and I substitute the values of the coordinates here into the x and the y here. So I have 0 that's less than or equal to 5/4 x. And what's x? That is 0 plus 6. So 0 is less than or equal to 6, which of course is true. So it does confirm it. So this does fall within our region. And of course, we could see here's 0, 0 right there, well within our shaded region. We could check another coordinate. Let's try something like -4. And how about -3? So here is our x and a y. I'm going to just substitute them into the x and the y in the inequality here. That's -3. That's less than or equal to 5/4 times x, which is -4, plus 6. That's -3. That's less than or equal to 5/4 times -4. That's -24, or in other words, -5, plus 6. And of course, -3 is less than or equal to 1. So that is satisfied. If we look at it graphically, here is -4 and down to -3, and it's well within our region. We could even check a value that we think might not be in the region. Let's try something like maybe -5 and 4. We just use this coordinate for the x and the y. So that'll give us 4. That's less than or equal to 5/4 x, which is -5, plus 6. 4 is less than or equal to 5/4 times -5. That's -25/4. As a decimal, that's -6.25. Plus 6. 4 is not less than or equal to, so we're just going to put a line through it. So 4 is not less than or equal to -6.25 plus 6. That's -0.25 or 1/4. And of course, here is -5 and 4 over here, certainly not falling within our region. So this does not work. So let's try letter B. So B has y is greater than or equal to 7x plus 3. And here is the graph again that I generated from the program within the text. We can see that here is our intercept, our y-intercept of 3. So our boundary line goes right through at 3. Our slope is 7. Every increase, positive increase of 1 along our x-axis, we have a positive increase of 7 along our y-axis. So we'll go over 1, up 7, 1, 2, 3, 4, 5, 6, and 7. We could also go back the other way, back 1, and then down 7. 1, 2, 3, 4, 5, 6, and 7. So we can see that we're landing on our boundary line. So then as we read this inequality, all the y values that are greater than or equal to this expression here, and of course we shade above that line. So now we can check some values that we think would fall in our shaded region. So I'm going to try -2 and 5. Again, we just substitute these values of the coordinates into the x and the y here. So this would give us 5, that's our y, is greater than or equal to 7x, and x is -2, plus 3. 5 is greater than or equal to 7 times -2, that's -14, plus 3. And 5 is indeed greater than or equal to -11. So then if I take a look at where -2 and 5 comes in, here's -2, 1, 2, 3, 4, 5, and here it is right here, well within our region. Of course, and we went ahead and we confirmed it. We can try another one. Let's keep it a little simpler, maybe -6 and 0. So then y would be 0, which is greater than or equal to 7 times x, which is -6, plus 3. 0 is greater than or equal to 7 times -6, that's -42, plus 3. 0 is indeed greater than or equal to -39. So this does lie within our region. If we go ahead and look at it here, we are at -6 and 0, and there it is right there. So let's finally try letter C. So we can certainly see for letter C, x is less than or equal to -9/2. There is no y-coordinate, and what that means is that any y-coordinate will satisfy this inequality. Not only that, but the boundary line becomes a vertical boundary line that passes through the x-axis at -9/2, and -9/2 is -4.5, and you can see that's exactly where it goes through right there. So whenever I test a value, the only coordinate I'm concerned with is the x value, the x coordinate. So if I did something like -7 and how about if we do -7 and 3, obviously we could see that's well within our region here, but any value that had -7, that's all we would want to check. So then we would have -7, that's our x. That is indeed less than or equal to -9/2, which is also -4.5. And -7 is indeed less than -4.5. We could also check any value within the region here. How about -5 and -7? That's way down here. All we really care about, -5 and -7, is the x value. That's the only one that we can use. So that's -5. That is indeed less than or equal to -9/2, which is -4.5. So we don't necessarily have to graph, though it does help, but we can check points to make sure that whatever half of the inequality that we shaded is the correct way by checking these points. And there you go.